So you're playing your favorite online multiplayer game, but you notice that the game seems to be lagging. Why does this happen? Well, to understand that, we need to understand how multiplayer games work. In order to have the game support more than one player, the game code has to be broken up into two pieces. The first is the client. Its job is to render the game's environment, entities, and animations that allow for the player to actually see and play the game. It's also in charge of managing the player's inputs and properly relaying the player's intents and actions, as well as to fill in the gaps between updates from the other half of the code, which is called the server. The server's job is to manage all of the players and their desired actions while also managing the game and all the updates that occur, like the position of a wandering cow or managing the collision of a laser the player shot. It does all of this while keeping each client that is connected to it in sync with one another. There are generally two types of servers as well, integrated and dedicated servers. Integrated servers are usually bundled within the game and allow for the ability to set up LAN servers as well as to actually run single player instances of the game. Dedicated servers, on the other hand, are only able to handle the server code and actions and have no physical client on them. They usually sit on a remote server and are typical servers you connect to for multiplayer games. In order for these two halves of code to talk to each other and communicate, especially when they're not on the same machine, games use packets to communicate. A packet is just a small bit of data that provides updates to the client or server about various aspects of the game. It's these packets where we find the first possible issue of server lag. There are two main metrics when we talk about packets being sent over the internet. The first is your ping, and while you may not exactly know what it is, I guarantee you've blamed it for your poor line skills in your game. Ping, similar to latency, is the time it takes for a packet to go from the sender to the receiver and back. The time it takes is affected by a few things. The biggest is the number of hops or servers that your packet gets routed through to get to its destination. How this all works is a topic in a video in itself, but the gist of computer networking is the internet is a connection between thousands of servers, all sending information between them. Packets are dynamically routed through these servers in various paths to get from the sender to the destination. More hops can increase your ping, and slow transitions from getting into and out of a server also affect these times. Your distance from the server does affect your ping, but much like package delivery, being close to a server doesn't guarantee fewer hops and low ping. Another factor is the physical wire that is transporting your packet. Fiber cables are generally able to transmit data from point A to B faster than copper cables, but not all the internet runs on fiber just yet, so the mix of the two your packet goes through will affect this time. In addition to ping, internet speeds also play an important role in transferring packets. Internet speeds, though, is a bit of a misnomer in the fact that it actually refers to the bandwidth of your internet. See, your bandwidth is a total number of ones and zeros that your internet can send in a specific period of time. Increase your bandwidth and you can send more ones and zeros in that time period, making your internet seem faster in the sense that you can send and receive more data even though the ones and zeros aren't actually traveling any faster over the wire. In addition to this, another misconception is that your internet is a choke point when it comes to game lag, and while that's usually the case, the truth is that any point along the transfer can become a choke point for bandwidth. The servers for the game, while having a much higher bandwidth than your local internet, also have to receive requests from hundreds or even thousands of players, which would create a choke point if there's not enough bandwidth to transfer all those ones and zeros to go in and out of the server. So now we know why lag occurs, but what happens when we get these issues? How do games compensate? Well, first off, most games run on a protocol called UDP, which means if a packet does not get from point A to B for any reason, the sender does not attempt to resend and the packet simply disappears. This could lead to issues like your gun not firing, a shot purchase not going through, or animations not correctly being started for other players' actions. While annoying, these actions are not critical to the game's integrity, and packet transfers have become reliable enough that even with UDP, the rate at which packets fail is relatively low. But what happens if a packet does make it from A to B, but just very slowly? When that happens, one effect we see is what is called rubber banding. Rubber banding is an effect where game objects seem to snap back to a previous location. This occurs because locally on your game, your system uses the previous information sent by the server to extrapolate about where objects in the game will go, and it uses this to fill in the time between update packets, smoothing their movement. This extrapolated movement could be wrong, however, due to changes in the missed packets, and when new changes are finally received, they can cause the game to have to drastically change an object to a state where you get this teleporting-like effect. Another thing that could happen is events occur out of order from your perspective. Because the server is in control of game actions and events, one player with a high ping could cause the server to process actions slower to compensate for the higher ping. Or the game may ignore that player's high ping and process the game events normally, causing the player with high ping to struggle to react to events since what they see may be a half second or more older than what other players see. These are just a few of the main reasons for lag, but computer networking is a complex topic in itself, and this is far from a comprehensive and in-depth list. That being said, we can all continue to blame the lag the next time we miss our skill shots on not moving targets. Hopefully you guys enjoyed the video. If there are any other computer science or related topics you want me to cover in a video, feel free to leave a suggestion in the comments below. Until next time, peace out.